cycle past CLRI, where Professor Nayudamma was the director. And I went to school here. So it's indeed a pleasure to be back here receiving this award. And I want to thank Bhaskar and Professor Ramamurthy for hosting this event at IIT Madras. While the intellectual arc of my journey began here at IIT and then went on to the University of Texas, and then as Professor Jagdish noted, I've been a long-time faculty member at Carnegie Mellon since 1988. I owe a great deal of gratitude to a number of folks, my classmates, including my classmates from high school who are here, and from IIT, Nagarajan who's here, and my PhD students, my master's students, my collaborators, colleagues, mentors, teachers. I owe a great deal to them for my being here in front of you receiving this award. My personal journey also began here in Madras. As I noted, I grew up here in Madras and went to school here. And a large number of members of my extended family are here. And while time precludes my naming each one of you individually, I want to thank every one of you for being here. You've been a great source of support. But I do want to call out a few of you specifically. My elder brother Kumar and his wife Anjana who are here. My siblings Tulsi and Harshada who aren't here, but have been a great source of support. My wife Rema, a scholar in her own right, who's also on the faculty at Carnegie Mellon, been an integral part of the journey that I've been on, and what's brought me here. She's had one transgression in her life. She went to the wrong IIT. She went to IIT Kanpur, but this being today, we'll forgive her for this one transgression on her part. My kids, Divya and Deepak, who are here as well, and my mother-in-law, who's come all the way from San Francisco to be here, and unnamed aunts. I mean, there are several of them here who've been doting aunts over the course of my life who are here as well. And then last but not the least, my parents, Lalita and Ramaya, who aren't here, but have been instrumental in everything I've done, and have been a great role model, both personally and through example that has led me to being here today. So thank you, everybody. This is also a good segue, this idea of the set of interconnections that I've had with all of you that's led me to today. It's a good segue, I think, to the talk I want to share with you, the ideas that I want to share with you, which is about people and their interactions and how digital technologies allow a way for us to both understand behavior and understand how these behaviors can best be understood to support a new way of thinking about dealing with societal challenges. That's really what this talk is about. I should note that rather than dwelling on what I've done or accomplished in the past, and it has been a very kind citation by Professor Jagdish, I'd really like to be forward-looking and aspirational in terms of what it is we could do in terms of the possibilities being enabled by technology. What I'm going to be talking about is data-driven innovation in a connected world. We all recognize we are living through this amazing digital transformation of society, made possible by computing, communication, networking, and this is having a transformative effect on all aspects of our economy, and has important implications for our national security, and has had an effect on every societal challenge that we're contending with. As I mentioned, I'm at the Heinz College, which is home to both a School of Information Systems and a School of Public Policy. these sets of challenges live at the intersection of technology, public policy, and management. And every one of these societal challenges that you see up here have been informed by and affected by and impacted by these developments in technology. I'm going to choose a few of them to share with you in a little more detail, the ones that I have spent some time thinking about in areas such as healthcare and transportation and in urban systems. And if you step back and ask yourself, what has been the key enabler of this digital transformation? It's been this remarkable set of developments in what are broadly referred to as smart sensing, the associated reasoning that goes with sensing, and the capacity to take actions based on the sense data. So think of this as a loop of sensing, reasoning, and action that one engages in. And what's been remarkable is that sensing has become remarkably cheap, remarkably ubiquitous, and it's been deployed in various sectors of our economy in ways that are having a transformative impact. I want to paint this in broad brushstrokes with 3 examples, but then talk about those aspects of sensing, reasoning, and decision making that I particularly have focused on, which is about people and their behaviors. But first, a broad brushstroke on how this is transforming elements of technology that you and I interact with pretty much on a daily basis. I probably need to run a video here. This is a speeded up video of the Carnegie Mellon driverless car. Okay, this is right outside CMU. So for those of you who went to CMU, you remember Pittsburgh. Now, you might think of this is now actually taking shape in products that are actually being deployed in market. So General Motors has employed these technologies. Tesla has employed these technologies. So I was at a driverless vehicle conference in Adelaide just 3 weeks ago, talking about issues of autonomy and intelligent transportation. And you might think this is just cool technology, but it's much more than that. Because if you think of what this technology is enabling, it's really transforming how safety on roads can be considerably improved. Not necessarily full autonomy, as shown in this video, though the technology is almost there, but a number of attendant kinds of technologies that have gone along the way associated with autonomy, such as intelligent transportation, the use of vehicle-to-vehicle sensors, vehicle-to-infrastructure sensors, are really allowing for a number of ways in which traffic safety is going to be fundamentally improved. If you look at the data from the US, there's been a considerable decline in the number of accidents per vehicle mile traveled and the number of deaths from these accidents. The data from India are particularly sobering. This is actually data from 2013 from India, where 377 people die every day in road accidents. And the idea of having technology coming from improved sensing and reasoning to reduce the number of traffic fatalities is a concrete example of how smart sensing, reasoning, and action making or decision making can really have societal consequences. Now, if you look at the social costs associated with driving, this is a RAND study from 2014, you'll see that accidents are a fairly important aspect of the social cost of driving, as is air quality and air pollution. So these elements also sort of give you a sense for where I'm headed in terms of bringing technology and social science and policy together. So this idea of illustrated in the context of the driverless car or intelligent transportation has broader implications. The second example, and can do a very brief video on this. It might be hard to actually hold the video. If you could stop the video, I can just talk through it. I think the audio is not good. So this is work done at Carnegie Mellon on the Boston bombing. So if you remember the Boston bombing, there were two bombers that bombed the Boston Marathon. And this work used a very grainy video from a surveillance video to recover the face of the individual, Dzhokhar Sarsenev, who was the 20th face out of 1 million faces that was identified by this technology from Carnegie Mellon. This is Mario Savides and the Biometric Center that actually enabled. Here again, the sensing was the video stream. The reasoning was the capacity to pick one face out of 1 million. And the action that was taken was to identify this individual and then apprehend him. So this is another example of how this smart sensing, reasoning, and decision making has really important societal consequences, in this case, in the context of public safety. A third example is in the context of transportation. And this comes from Steve Smith at our Robotics Institute as part of a project that we run called Metro 21, which is a smart city project. And what this does is it uses adaptive traffic light signaling, where there's a camera that figures out the flow of traffic, and based on the flow of traffic determines the scheduling of lights. The important aspect of this is it not only reduces the waiting time for vehicles, it improves air quality because cars are not idling at the traffic light. So here again, so there are three examples, one about driverless cars, the second in the context of biometrics, and the third in the context of intelligent transportation, each one of them enabled by smart sensing, reasoning, and decision making. So with this as context, what I'd like to do is to sort of move to what I'd like to focus on, which is how can you think about this reasoning, sensing, reasoning, and decision making being applied in the context of people and their behaviors, and how can we design a new class of systems that I call cyber physical social systems that takes people and their behaviors into account and how they interact with one another and with their devices and with their built environment, and how sensing and reasoning and decision making can allow us to create these new class of systems to address societal challenges. So we talked about people and their interactions. Among the two major technologies that you're all familiar with, and in fact every one of you probably carries a device, a phone with you, has been the mobile phone and the near ubiquity of the mobile phone. And this mobile phone, we expect very soon to have more mobile connections than there are people. So 9.7 billion by 2017 in terms of number of connections. And if you take these mobile phones and think about them as having a number of sensors in them, so most of our smartphones today will have a camera, it'll have a GPS, it'll have an accelerometer, it'll have a video camera in them. So the camera has a number of, the phone, pardon me, has a number of sensors with it, and thereby the phone as a device allows people to sense the environment in ways that were previously not possible. So we have moved from a society that was networked to one that's always on, and via mobility and through the advent of social technologies have gotten to be networked in ways that allow us to observe the set of interactions. So this is sort of an important point, which is that the sensing technology allows you to observe the interactions that people have with one another versus having to obtain via survey or opinions about what kinds of behavior people engage in. You actually have an observatory that permits you to actually observe the kinds of interactions that people have with one another. That's sort of, and it has interesting and important implications for privacy. It has important implications for security, but I think this is a big shift in terms of what's going on. So if you think of mobile and social, it's also interesting to see how quickly mobile and social have achieved near ubiquity in terms of adoption. So if you compare the number of years it took for radio to achieve penetration up to 50 million users, it was 38 years. TV took 13 years, Facebook took a year, and Twitter took 3/4 of a year. So this is accelerating in terms of the number of years it took for this kind of scale of adoption to take place. So there's this very rapid rise of social. And when you combine social with mobile, you get this remarkable set of interactions, the network of interactions that people have with one another. And I want you to think of those little icons just not as people, but people interacting with people, people interacting with devices, devices interacting with other devices, to have a very rich set of interconnections of people with the built environment that they're in. And this is really the world we are headed into. If not now, we certainly are headed there in terms of these sets of interactions. Now, if you're able to capture these interactions, reason about them, and take decisions, then you're able to both explain behaviors as well as to be able to design systems that can address societal challenges. So oftentimes when you think about these kinds of interactions, you ask yourself, how are these interactions producing information about behaviors? I said the new technology provides an observatory. An observatory implies that you have data about interactions becoming visible. So certainly one of the major elements of this shift has been this capacity to capture data that is voluminous, that is of different data types. It's not just about numbers, it's about text, it's about images, it's about video, it's in real time, and the veracity and the provenance of that data is often something you need to be concerned about as well. So these are all different factors that one needs to take into account in terms of characterizing the data that the sensing is going to provide. And as you move from data to knowledge to action, this is really where the crux of the opportunity lies, which is this marriage between data science, and it's really interesting to see that IIT has established an institute or an initiative in data science that brings together faculty from multiple departments. This is certainly happening in many universities. And in particular, I think for the kinds of activity and behaviors that I'm particularly interested in, this marriage between data science and social science is of particular interest and relevance. Now, I should point out that all of this seems to be moving towards a story of this being about big data or big decision. Big data has become a bit of a buzzword. I would like to say that this is really not about just big data. It's about data, be it big or small, data that has deep context, that really has value. And the question is, how do you unlock the value that's in the data? And that requires you to bring together data science and social science. So let me step back for a minute. So what I've told you about is this idea that we have a new class of systems. I'm calling them cyber-physical social systems. And what they're about are about allowing for this loop of sensing, reasoning, and decision-making to take place. And that the sensing is allowing for people and their interactions between themselves